example. And about the next example, we can take this, a quick one. Let us look into this, and before that, let's try as much as possible. Yeah, very good. So we can start. More example, let's take the next one. We have an integrand of x over x plus 1 dx. So I've said with more examples, you are going to be getting how to integrate without having any issues. Now, looking at this, what we do here is that, like my method, I told you, you are looking for a variable that will consume either numerator or denominator. Here, there's no such variable that will consume each other. So in this type of expression, method you can use is just to redefine the equation. As you can see, you can write this in another form. So I can say this is same as saying x plus 1 minus 1. As we all know that plus 1 minus 1 will give us 0, which is this, all over x plus 1 dx. So what I'm trying to do is that I'm looking for a situation whereby what is up will be the same thing as what is down. So I haven't done this. I can even say this is also the same thing as, I hope students are following, saying we have integral, or I can do it in s1, s plus 1 divided by s plus 1 is same as saying 1, I want to write this in normal fraction, minus, this is 1 all over x plus 1. I hope students still get this. What have I done here? If you do this in your normal primary school evaluation, going by LCM, LCM is x plus 1, which is here, then 1 in x plus 1, x plus 1, then x plus 1 minus. So what I'm saying that this expression is the same thing as this. I just did this over this 1, and I took the remaining 1 over minus 1 over x plus 1. So I just redefined it because it's now very easy for me to integrate. So therefore, the answer to this is that we all know that if you integrate 1, you are going to get x. Then if you integrate 1 over x, already discussed, it's going to give you natural log of x. So here, if you integrate this one, it's going to give you natural log of x plus 1, then plus the arbitrary constant. So please always keep this in mind and don't make mistake. Now, something has happened here because I did not give you a direct formula for how to integrate 1 over when you have the coefficient of a linear function. So, and if you look at it, the only function I gave to you is 1 over x, which I said is natural log of x. But 1 over x plus 1, I'm saying it's natural log of x plus 1. So now my question is, this is x plus 1, excuse me. So the question is, what about if it is 1 over x 2x plus 1? Will it be ln 2x plus 1? No. So we can talk about some generalized formula, which I think is going to help us also in understanding more on integration, because there is no specific formula for integration. So just try and know the method we employed to solve each category. So let's talk about some generalized formula for linear function. Let me just give you, let me call it a generalized or general formula for linear function. Now, the first one, which I think we can keep in mind here, is to always look for a situation whereby we have ax plus b to the power of n. So if we have to integrate, very important, ax plus b to the power of n, the logic is, now you just look at the coefficient of what you have. You can see what we did the other time from the formula was x to the power of n. Now we are now having a coefficient in the form of a and also have another one. So this is a linear function to the power of n. So what we do here is just, you can actually do this in different way if you want to prove. Maybe you are doing a kind of questions that you are to prove on how to get this. But directly, this is just saying, what we take is just saying, we take the coefficient of a here, we'll go for the inverse. We say 1 by a, then we go for what is in the bracket. We have ax plus b, then we follow the law, we add 1 to this, then we divide by n plus 1, then we have plus the arbitrary constant. So generalized formula we use for this type of expression is very, very important. And you can also prove it by substitution method. Now here I can say let t be equals to ax plus b. So if t is equals to ax plus b, so you can say I will have t raised to power n. If I differentiate t raised to power n, it's going to give me t raised to power n plus 1 over n plus 1. So if I differentiate ax, I'm going to have, everybody knows, we know I'm going to have a. If I differentiate 2x, I'm going to have 2. So if I put that, it will be 1 over 2, just like what we've been doing in our previous example. So whenever you have an expression in form of a linear function and it's in form of a linear form of equation, just go for the coefficient of the power of the linear function. You are going to go for the inverse of it. Repeat the normal method. You have the answer right in front of you. You can take some example on this. Let's take some example. Or basically, maybe we should give another way in which you can also see function before going for example. Look at another expression. If I have an integrand of, let's say, inverse of 1, just like what I did here for understanding sake, all over ax plus b. Then we have dx. What I've done here exactly is what I want you to see. Now, what we do here is just the same, just like what I did here. You can see 1 over the coefficient. Look at it, we have a. So we have 1 over a. Then you have, you open a bracket for your ln of ax plus b. Close the bracket. Then you have plus the arbitrary. This is what I did here. You know, normally it is 1 over x that is natural log of x. So I have 1 over x plus 1. What is the coefficient of x here? 1. So it should have given me 1 over 1, which is 1. So 1 over 1, natural log of what I have. Ax plus b is x plus 1 plus c. So this generalized formula is going to help you a lot when you see some questions. So that is why you have to keep it in mind. So please don't make mistake in keeping all this in mind. We can take another one in terms of trigonometric functions. You can have generalized function. So the third one, we can say we have this expression. We have the integration of sine, very good, ax plus b dx. So the generalized formula you can use for that directly is also very, very simple. As you know that we said it will always be coefficient of this. So you have 1 by a. When you integrate sine, everybody knows you are going to have minus cos. So you have minus cos. Repeat that, ax plus b, then plus the constant. So this is very, very important to keep these three formulas in mind. So directly you can get answers without wasting time. Now, let's take some example for this slide before we call it a day on this one. We can say the first one, we have examples as usual. To have a proper knowledge of our physics, that is why we are doing all this stuff. Now we have our integration of e to the power of 4x plus 3, as you already studied. Now here, the answer to this directly will be you study the coefficient. Remember I told you, this is having the x, please. That's the question. So to solve this one directly, if you don't want to use the substitution method, you can use the generalized formula. So here, directly, you know, e raised to power x is the only value that doesn't change in both integration and differentiation. So normally you can say let t equals to 4x plus 3, e raised to power t is t raised to power t. Then we have, we differentiate t. We are going to have 4x plus 3 will give us, the t ds will give us 4. Then we know when we come by it will be 1 over 4. That's a long processes. These are long processes. So you don't need to waste your time. Look at the coefficient here. The coefficient here is 4, just like what I've talked about here for x or whatever. So you have 4 here will be 1 over 4. So then you repeat this, you know, it will be e raised to power, that is e raised to power 4x plus 3, then plus the what? Arbitrary constant. That will be the question answer. I hope students are getting this generalized formula of getting answers to integration. So please, and if you want to prove if your answer is correct, you can always differentiate it back to check if you are correct. So because we say integration is direct opposite of differentiation. So next one, we can take more examples. To take one more example, we can go by saying, let's take one or two more. Let's say we want to integrate another one, cos square x dx. Very good. As we can see here, cos square x dx is not cos 2x. If I'm to integrate cos 2x directly, I can apply my formula and get this. Now, to integrate this, we have to bring in our trigonometric values. So we have to be very, very careful to go and understand all these bases of trigonometric value. Now, for what we have learned in early classes, for those who are not so good in trigonometry, you can keep this in mind. We say cos 2x is equals to cos square x, 2 cos square x minus 1. Sin 2x is 2 sin x cos x. But I don't need that yet. I can help you write it out. Sin 2x, because all these are bases of trigonometry. These are 2 sin x cos x. We are going to be needing all these stuff in our physics. So now we said here, if cos 2x is equals to cos square x minus 1, 2 cos square x minus 1. So we can say from here, and we know that cos square x minus sin square x, another one you can keep in mind, cos square x, we have cos square sin square x, let me write it well, plus cos square x is equals to 9. These are bases of trigonometry formulas or identities you can keep in mind. So what I do here, guys, is just a direct substitution. So if I know that from here, I can try as much as possible from this one. I'm going to use the first one. I'm not going to rush because I want you guys to get it, because it has something to do with the expression I have here. There is no direct formula for integration. That is why we need to go through all these processes. So, and I'm going to show you every details you need for basic and for a little bit of advanced for JUPEP students in particular, and for our A-level students in the examination. And some of you writing UTM too, you can come across this, and further math students. So that is why I'm taking my time to help you. This is majorly for physics class, but because it is also very important in mathematics, that is why we are taking our time on it. So back to what I'm saying. Here from here we can see. So I can make this one sort of formula. So I can say from here that 2 cos square x is equals to cos 2x plus 1. I hope students understand this. So if I go by that, so I can say cos square x is now equals to 1 plus cos 2x divided by 2. So this is the value I'm going to change my expression to before I integrate. So I'm going to go for integration of this expression is now the same as this. 1 plus cos 2x divided by 2. I hope students are following. So why do we need to go through all this process? I said there is no direct formula for integration like differentiation. So learning all these processes are very important, and please don't get tired because we still have a long way to go. So here we say is equals to, we write this equation, you can see integrand, there's the x, please, very important, 1 by 2. Then you can also say plus cos 2x also divided by 2. I hope you understand the way I always reform all my stuff. So because it is now very, very easy for me to integrate, because I know I can actually bring this one out if I integrate 1 over 2 with respect to x. As you can see, we can say this is the same thing as 1 over 2 will give me 1 over 2x. I hope students remember. So far 1 will give me x, 1 over 2 will give me 1 over 2x. And if I have this one, now I can remodel this one because I know this is going to give me, please students, I can now use my direct formula of what I have here whenever I have numbers in this form. So I can say this is simply as saying I want to rewrite this equation now. This is simply as saying plus, look at here, I'm going to have 1 over 2, because that's the coefficient. You can see coefficient of x here is 8, coefficient of x here is 2. So when I integrate cos, everybody know I'm going to have sine. So I have 1 over 2, open bracket. I'm using the direct formula. As you can see, the bracket here then it's going to give me sine, then I have 1 over 2, then I have sine 2x, sine 2x, then I have a plus c. So maybe I should take that again for understanding's sake. I integrate 1 over 2, everybody knows it's going to give me 1 over 2x. Here, this expression here cos 2x over 2, let me say 1 over 2 cos 2x. So for understanding's sake, you can see, what I'm trying to say here is that if I integrate cos 2x, normal, this is going to give me, excuse me, you have, from the formula, coefficient here is 2. That is, I have 1 over 2. And there's another 1 over 2 outside here. So that is why the 1 over 2 is coming outside here. Then I will follow the law. I will integrate cos. Cos will give me sine. Then I repeat the expression of the linear form. The linear form expression here is what we have as cos 2x. That is I have, after integrating, I will repeat that one. That is 2x. Can you see this? 2x plus c. So if I actually integrate cos 2x, I'm going to have 1 over 2 sine 2x plus c. If you did not get how to integrate cos 2x, you can use our substitution method, which we have explained here. Let t equals to 2x. So you have cos t. If you integrate cos t, you are going to have what? Sine t. And t is 2x. That's sine 2x. Now, if you integrate 2x, if you differentiate 2x, you are going to have 2. So if you take it back, it will be 1 by 2, like what I said. So always have it at the back of your mind. For example, for understanding's sake, if I have someone asked me to integrate cos 2x now. The coefficient here in linear function is 2. So I'm going to say it will be 1 over 2. I will integrate cos, the direct formula I'm giving to you here. If I integrate cos, we know it is what? It's sine. So it will be sine. The function itself is 2x plus c. I hope it is okay in this format. So keep it in mind. If it is sine 2x, simple to do. The same method. 2 is here. If it is 3, it doesn't change anything. The algebra form here is 3x. It will be 1 by 3. Keep it in mind. That is what we are explaining here. So then sine will give me minus cos. Then I have what? Repeat the 3x. You have 3x plus c. I hope this is okay. And that is exactly what I did here. 1 over 2 will give me 1 over 2x. Students should get this. So there is 1 over 2 here. That is why I'm writing this expression as 1 over 2 cos 2x. I'm taking my time because I don't want issues. So 1 over 2 will be outside here. Then taking the other one, you can see this. So it will be 1 over 2 times 1 over 2 because this cos 2x itself is giving me 1 over 2 sine 2x. Then multiply by the 1 over 2. So what's 1 over 2 times 1 over 2? Everybody should know that. Answer will be 1 over 2x plus 1 over 2 times 1 over 4. 2 will give me 1 over 4 sine 2x. Then what? Plus c. So if you want to confirm this answer, you can differentiate it back to check if your answer is correct. And I can tell you that it is 1001% correct. So let's take in one last example. And we know in the next slide, we are going to talk about definite integrals and limit. So let's see next example, and which will be the last example. Now about this one, we can say we have the last one, which I think maybe I should give you in form of classwork. You can try that. Integrate sec to the 4th power of x multiply by tan x dx. So just directly you can use the substitution method to do this. Let me give you a clue. This will tan x will consume sec x. So you can just say let t equals to tan x. You know, when you differentiate that, if t equals to tan x, the t dx will now be the t substitution method. It will now be equals to, that is what we have as sec square x, or sec x tan x dx. I hope students remember this direct formula when we take I said let t equals to tan x, sorry, let t equals to sec x, because sec x is what we will absorb that. I will not make mistake. So sec x, when you differentiate sec x, you have sec s tan x. So please pardon my mistake. So if t is equals to sec s, so now, and the t is now sec s tan s, if you substitute back here, what you're going to have in this expression, if you are following, You know, t is sec s. You should have t raised to power 4 to show you, multiply by what is here was tan x dx. And I already now have the x in this format. If you want to bring it back, is equals to the t divided by, I hope students are following, sec s tan x. So this is what I am going to substitute where I see the x here. So if we go by that, it will be t to the 4th power times tan x now, which I have here, we come as tan x, multiply by, look at this, this is the x line is now the t upon sec x tan x. So from here, tan x gets cancelled out. You can see what you have. So this is what method I want you to use so that you can actually get the answer. So if you can use this method, the expression will be so simple, then you can actually always break it down. So follow this method. Let's see if you can solve it and drop your answer in the comment, because now it's now very, very simple. You have it in terms of the t, and you know you can actually integrate sec s. So now it's now simple. What you have is t raised to power 4 over sec s, which is kind of very simple to do. So guys, I will stop here. I want answers to this. Let me see if